Assalamualaikum. Okay, we will continue on discussing for the solution question 2 assignment 1. Okay, for question 2a, the question asks to complete the blank cells of the above table accordingly, and you need to describe the condition of the steam as whether it is compressed liquid or mixture or superheated vapor, or insufficient information if applicable give the quality. So you need to show the value and how you get that value for maybe the justification on how you stated that the process has the condition of maybe compressed liquid or superheated vapor, so you need the justification. Okay, move to the first process, which is process 1. Given temperature 400 degrees C and a specific volume of 2.3, and it required to find the pressure and internal energy, as well as you need to describe the condition of the substance or steam water at that conditions. Okay, referring to table E4, you can see that the temperature is up to 373, if I'm not mistaken, 373.95. So we can jump to table A6, which is superheated vapor, because at this in this table you may have more information at high temperature. So by referring to superheated vapor table, and by using the other information, which is specific volume of 2.3 at 400 degrees C under 0.1 MPa, the value of V is 3.1. At 400 degrees C under pressure of 0.2 MPa, the value of V is 1.5. Given 2.3 as the V value, so you need to interpolate the pressure between this range of pressure 0.1 MPa and 0.2 MPa for the specific volume given 2.3 in between 3.1 and 1.5. So you will get the pressure at T 400 degrees C and V 2.3, and same procedure or same step you are going to use to find the value of internal energy. Okay, so that in the blank cell of condition description, you may put the justification as superheated vapor because of temperature of in table E4 is limited, so that it is under superheated vapor. Okay, move to the process 2. Given pressure and temperature, which is 200 kPa and 200 degrees C. So in order to know what is the phase of this steam water, we need to refer either table E4 for temperature as a reference and table E5, which is pressure, as a reference. Okay, let's say we take pressure as a reference. P equals to 200 kPa. So in this table, the T set will be 120.21 degrees C. By comparing the given temperature, which is 200 degrees C greater than T set, So we can claim that the phase is superheated vapor. And then the value for V and U, you need to find the value in table A6, which is table superheated vapor. Okay, next process 3, given 530 kPa and internal energy of 3084. Under table A5, we already know that the value of U greater than the UG at 500 kPa. So that we need to refer table A6, which is superheated vapor at 500 kPa, because of in the table we just have 500 and 600, so it's okay to assume that pressure is 500 in order to ease the calculation, so you don't need to make an interpolation for many times for pressure, and then you need to interpolate for temperature, then need to interpolate the other properties like V, so that we just assume pressure 500 kPa. So the value of U3084 is in between temperature of 400 and 500 degrees C. So you need to interpolate the temperature between these two temperatures to get the T set. And then V as well, you need to interpolate in order to get the value for V. So the description on the phase is superheated vapor. Proceed to process 4, pressure 300 kPa and V 0.45. Then referring to table E5, at P equals to 300 kPa, we find that the value of 0.45 is in between VF and VG, so that the phase is saturated liquid vapor mixture. In order to find the U, we have to use the formula U4 equals to X VFG plus VF, or we need to find the quality by V average minus VF over VFG. Okay, lastly, process 5, given pressure 255 and temperature 110. By referring table A4, at T equals to 110 degrees C, P set is 143 kPa. If we compare between P given and P set, so we can find that P given greater than P set, so that the phase is compressed liquid. So how we would like to determine the specific volume and internal energy at this condition, because if we refer table A11, which is compressed liquid, we do not find the pressure under 255 kPa. So in the absence of this compressed liquid data, so we can treat the compressed liquid as saturated liquid at the given temperature. In this case is 110 degrees C. This is because, as you know, the compressed liquid properties highly depending on temperature, much more strongly than they do on the pressure, so that any properties that we can represent as y equal to yf at a given temperature. In this case v, so v equals to vf at temperature given, and u equals to uf at given temperature. Okay, for the question 2b, based on the above conditions, plot the properties in PV diagram and provide enough data and labels to indicate each phase involved. Okay, by plotting PV diagram for each process from 1 to 5, so you just plot pressure in the y-axis and V specific volume for x-axis, that you just key in the value that you have calculated in question 2a. So by having this work profile, then you need to solve for the question 2c. Okay, so considering linear work profile in the previous slide, so determine the work and heat transfer for each process above, and discuss the process based on the movement of cylinder piston. Okay, so from the profile, we can just take out one by one process and calculate the work done and heat transfer involved for each process. Okay, I just give you one example, and then you just need to repeat the similar steps in order to calculate for the other process from 2 to 3, 3 to 4, and 4 to 5. Okay, for the process 1 to 2, P1 equals to 152 kPa, and specific volume is the volume is 4.6 cubic meter. P2 200 kPa, and V2 is 2.16 meter cube. So constructing this diagram or graph, P versus V. So you just considering the under area under the graph. So work W equals to half multiplied by 200 plus 152 multiplied by 4.6 minus 2.16, so that you get work done 429.26, which is positive, means that work done by the system. And then for the heat transfer, using the general energy balance, so delta E in minus delta E out equals to delta E of the system, and then represent the E in and E out as well as E system. Q minus W equals to delta U, because of we neglect delta KE and delta PE. By using the value of work done, which is 429 kilojoule, so we will get the value of heat transfer by calculating as well the internal energy for state 2 and state 1. So the heat transfer in this process is exothermic, which it release 196 or 197 kilojoule of heat. Okay, so that for the process 2 up to process 5, you can just calculate by using the same step of this calculation. Okay, thank you.